Kirkwood Math. Hello and welcome to 6.2 Rates as Comparisons. We're going to go ahead and take what we learned about rates and unit rates, and we're going to use them to solve problems using comparisons by finding those unit rates and comparing. So in this, we're going to be able to find unit rates, and then we're going to use that unit rate to solve problems. All right, in this first one, we have a travel agent is preparing 3 different car rental quotes for her customer, as shown in the table below. We need to find the cost for 1 day for each of these places, and then we need to figure out the cost of renting a car for 10 days from each place. And in the end, we're going to figure out which rental shop has the best value. So in order to find the cost for 1 day, we need to divide. Now you can see that none of these dates match across all 3, so I can't use any of these as one thing. So in order to find the cost for just 1 day, I'm going to take the smallest value and I'm going to divide. So I'm going to do 109 divided by 50 over here, 109.50 divided by 3. I'm going to do 71 and 50 cents divided by 2. And for value vehicles, I'm going to do 111 divided by 3. So I'm going to pause the video, go ahead and take your time, do this division, and then join me in a minute. All right, so I got $36.50 for Thrifty Voyage, $35.75 for Frugal Ride, and $37 even for value vehicles. And this is the price for 1 day. Now, normally you would want to divide every single one of these to make sure that it's the same, because maybe the more days you do, the higher discount you get, so it's cheaper. But if you do these on a calculator, if you were to do long division with these, you would see that they are all the same price per day. You could even just try to go, okay, this is 2 days ahead, so if I add $36.50 twice to $109.50, I would get $182.50. You could do that too. What we're going to do now is see for 10 days. Now this is pretty easy because we're going to times everything by 10, which just means I'm going to move my decimal 1 place to the right. So for 10 days, it would be $365 for Thrifty Voyage, $357.50 for Frugal Ride, and $370 even for value vehicles. Which one has the best value? Well, it would be the cheapest one, which is Frugal Ride. And it was cheaper per day anyways. $357.50 for 10 days. The only way that we could tell which one was the best deal was by finding a value of 1. If I compared my 2-day one to my 3-day one, it wouldn't quite make sense. Yes, this is smaller, but it's also less days. So by finding it for 1 day, it's easier to compare. Okay. Types of rates. Rates can be useful in comparing different quantities so that problems can be solved. Rates can be solved using tape diagrams or proportions, which we've been using as equivalent ratios right now, just like ratios. So like with prices and speed. So we're going to go ahead and use our understanding of rates to answer these questions below. A manufacturing line can produce 15 widgets in 2 minutes. How many widgets can the line produce in 30 minutes? So we're going to set these up using equivalent ratios. You could do tape diagrams, but I don't really want to draw 15 boxes. So instead, I'm going to do line equals line or bar equals bar. This is my current ratio. This is my future ratio, or in this case, rate. This is my rate. Remember, a rate is just a special type of ratio. I am comparing widgets to minutes. Widgets to minutes. I know currently we can make 15 widgets in 2 minutes, but how many widgets can I make in 30 minutes? So I'm going to go ahead and use my equivalent ratios. I know that 2 times 15 is 30, so I need to do 15 times 15 to get my answer. Okay, if I do a little bit of math over here, 5, 6, 7, add my space holder, my placeholder 0 here, because now I'm going to multiply by tens. My 10 times 5 is 50. That's why the 5 is going there. And then 1. 5, 12. So I can make 225 widgets in 30 minutes. And that's my final answer. So comparing rates and using these comparisons to solve is just very similar to comparing equivalent ratios or making equivalent ratios. Okay. A dripping faucet leaks 10 milliliters in 3 minutes. How many minutes will it take to produce 140 milliliters of water? Same thing. I'm going to compare milliliters to minutes. 10 milliliters in 3 minutes. 140 milliliters, and I don't know how many minutes. Well, 10 times 14 is 120, so 3 times 14 will be my answer. Forty-two minutes to produce 140 milliliters. Okay. Now in this one, we're going to be comparing these rates and seeing who's better. We have to answer questions like which one's the better value or who can type fastest. Number 3, a 12-pack of orange soda, 12-pack, is priced at $3. A 6-pack is priced at $1.75. Which is a better value? So for these, I need to find unit rates. And to find unit rates, hopefully you remember, that means I need to divide. So I'm going to do 12. Well, I need to know which one's the better price. And in order to find the better value, I need to know how much for one. I need to know how much money for one soda. So that means I need to do money divided by sodas. So I'm going to do 12. Nope, that's not money. I need to do $3 divided by 12. And I need to do $1.75 divided by 6. And once I get my unit rates, I can compare. Don't forget to move your decimals straight up because we do not have decimals in the divisor. And we can go from there. 12 goes into 3 0 times, but it can go into 30 2 times. 12 goes into 65 sides. That's 25 cents per soda. All right, 6 goes into 1 0 time, but it goes into 17 2 times. Six goes into 55. Well, 9 times would be 54, 9. And then that's 10. One time. That's 40. It's going to keep going, right? So we have about 29 cents per soda, and we have 25 cents per soda. Which one is a better value? It's going to be the 12-pack because it's less money per soda. All right. Anna can type 123 words in 3 minutes, and Caroline can type 220 words in 5 minutes. Who can type faster? Again, I'm trying to find unit rates. I want to know who can type how many words in 1 minute. And then I can compare. So I'm going to do words divided by minutes. Words divided by minutes. That's 41 words per minute for Anna. And 42 words per minute for Caroline. Now, because I'm trying to figure out who's fastest, the more words per minute wins. So Caroline is the winner. All right, next one. May can read a 403-page book in 13 hours. At this rate, how long will it take her to read a 248-page book? Okay, we're back to equivalent rates or ratios. Pages, hours. Pages, hours. Currently, we're reading, 403 in 13 hours. How long will it take her to read 248? So I don't know. These are really big numbers, so I don't know what this is. So I'm going to have to do some division. I'm going to have to do 403 divided by 248. 16, 8, 9, 4, 6, 96. So it's just going to be 1. It doesn't seem right. Eight, 9, 10, 11, 12, 13, that's 5. 5, 1. Add my decimal and my 0. Okay, I have to figure that out. Let's see. 15, maybe 6. Let's try 248 times 6. I'm going to pause this so we don't take up our whole video doing division. All right, so once I did that long division, it was kind of a long problem. I got 1.625, and it ends evenly. But this is not my final answer. That is just what I would be really multiplying the other way, right? So I would be dividing, in this case, 403 by 1.625 to get 248. So now I would have to do the same thing to 13 to figure out my answer there. So I'm going to erase my long division here so that I can have room for this new long division problem. And I'm going to do that. So I'm going to do 13 divided by 1.625. Now, in this problem, remember, my whole number's decimal point is here. But because I'm dividing with a decimal on the outside, I need to move this to the end. 1, 2, 3 times. So I'm going to move this decimal 1, 2, 3 and fill with zeros. My decimal point will go straight up in my answer, and I'm now doing 13,000 divided by 1,625. Again, I'm going to pause here and do this division to save some time. All right, so 1,625 goes into 13,000 8 times evenly, which means that it will take me 8 hours to read that book, read 248 pages. All right, one more thing. Let's see if we can squeeze it in here. Oh, I guess we have some more practice problems, but so I wanted to show you this one. This is another tape diagram here. So it says during a thunderstorm, a local news reports rainfall at 1/2 inch per hour. How much rain will fall if it continues for 8 hours? And then there was a tape diagram below. So underneath this was just a nice bar like this. And what we ended up doing was dividing it into even chunks here. Rainfall on top, hours on the bottom. So because it was 1/2 inch per hour, we then did tick marks to go all the way up to the 8 hours. So we did 8 tick marks, 1, 2, 3, 4, 5, 6, 7, 8. And each of those tick marks represents 1/2. And that's how we got our answer of 4. Now, if you wanted to do this the traditional way that we've been doing with equivalent ratios, you would set it up the same way with 1/2 of rainfall on top and the hours on the bottom. I wanted 8, so I needed to know how many inches of raindrop went here. 1 times 8 is 8, and 1/2 times 8 is 4. And that's how we got our answer that way.